This video is about the multiplication properties of exponents. The goal of this video is to use the laws to simplify exponents. So there's a couple of different laws that we're going to learn today. The first law is the product of powers. This is what happens when multiplying powers that have the same base. You add the exponents and the base does not change. So, for example, we have 2 times 2 to the 5th. This really is an exponent of 1, so we're going to add our exponents. Notice the 2 stays the same. We add 1 plus 5, and we get 6. So let's try some examples. Number 1, 5 to the 5th times 5 squared. So our base is 5, it stays the same. Our exponents, we're going to add them together. 7 plus 2 gets us 5 to the 9th. Number 2, instead of a number, this one is a variable. It's the same idea though. So we have v times v to the 12th. So remember that v has an exponent of 1, so we have v and we're going to add 1 plus 12, so we get v to the 13th. Number 3, f to the 9th times f to the negative 5th times f to the 2nd. So there's 3 variables with different exponents. They're all the same variable, which means our base stays as f. And we're going to add 9 plus negative 5 plus 2, which gets us f to the 6th. Number 4, negative 2 squared times negative 2 to the 11th times negative 2 to the 6th. So our base is negative 2. We need to keep the parentheses because we want the negative to stay with the 2. We're going to add our exponents. 2 plus 11 plus 6. So when I combine like terms, I get negative 2 as my base, and I add to get an exponent of 19. Number 5, now our variables have coefficients. So we have 5g to the 12th times 3g to the 20th. Now, 5 and 3 have no exponents with them. So we can multiply those together because they're just coefficients. Coefficients are allowed to be multiplied together. And then we have g, our exponents are 12 plus 20. So we get 15g to the 32nd power. The same thing happens in number 6. 4n to the 5th times negative 3n to the negative 2 times n cubed. So our coefficients of 4 and negative 3 get multiplied together out front. And then we have our variable n, and we're going to add our exponents. 5 plus negative 2 plus 3. So we get negative 12n to the 6th power. Number 7, this is where we have different bases. So in this case, we have 2x to the negative 2 times 4x to the 8th times 2y to the 2nd. So we can still multiply all of our coefficients. We can multiply 2 times 4 times 2. With the x, we're only going to add the exponents of negative 2 and 8 because those have the same basis. The y to the 6th gets left alone because there's nothing to combine with. So when I multiply, I get 16 x to the 6th, y to the 6th. Number 8. Now, in number 8, we're not going to multiply these numbers together because they're different bases. So we're going to worry about combining negative 3, and we're going to add those exponents. 4 plus 3 times 5, and we're going to add the 5 exponents, which are 13 and 8. So we would get negative 3 to the 7th times 5 to the 19th. Nope, sorry, to the 21st. Number 9. So our m has coefficients of 3, 10, and 5. So those get multiplied together. Our m, we're going to add our exponents. Remember, if there isn't an exponent, it has an exponent of 1. So we have 3 plus 8 plus 1. And then k to the 12 plus 14. So when I multiply 3 times 10 times 5, I get 150. M to the 12th, k to the 26th. Another property is a power of power. So when you have one base raised to 2 powers, you want to multiply the exponents, and the base does not change. So here we have 3 to the 4th raised to the 5th. We're going to multiply the 4 and the 5, but the base stays the same. So in number 10, we have in parentheses 3 to the 3rd, and then raised to the 5th again. So we're going to do 3, and we're going to multiply our exponents. 3 times 5, so we get 3 to the 15th. Number 11, we have c to the 9th raised to the 3rd power. So our base is c, and we multiply 9 times 3, which gets us c to the 27th. Number 12, we have parentheses negative x to the 4th raised to the 4th. So negative x is our base. It stays in parentheses because we want that negative to stay with the x. And then we multiply our exponents. 4 times 4. So we get negative x to the 16th. The last property is the power of product. So what happens here is we are going to have a lot of things multiplied. So we are going to distribute the exponent to each term inside. So when we distribute, remember that we're going to multiply if there's already a power there. So I have j to the 3 times 3, k to the 11 times 3, and m to the 5 times 3. I'm going to multiply that all out. I get j to the 9th, k to the 33rd, m to the 15th. We're going to do the same thing in number 10. Number 14. We're going to distribute the power of 10. It goes to everything, including if there's a number. So this one, remember, has an exponent of 1. So we have 5 to the 1 times 10, a to the 9 times 10, b to the 2 times 10, and c to the 5 times 10. So we get 10 to the 5th, a to the 90th, b to the 20th, and c to the 50th.